Good morning. I'm delighted today to be joined by Jay Nagley. And thanks for joining us today, Jay. Today, Jay will be discussing the UK's 2030 shift to electric vehicles and decarbonisation. No small challenge, and I'm sure you'll all find the presentation really interesting. Any questions? Put them through the site and we'll endeavour to answer as many as we can. So thanks again, Jay, and everything's over to you now.
Thank you very much indeed, and good morning, everybody. I'm just getting up my presentation here. Just bear with me 1 second. So, can everybody see that okay? So, okay, great. So to begin with, let's establish what the targets are. As most people know, it's hybrid or zero emission by 2030 and fully zero emission by 2035. Now, what does that actually mean? Hybrid is going to be defined next year. There'll be a consultation period starting first or second quarter of 2021, where the government will invite comments on what it should be. Broadly speaking, the plan is that it will be a range which will allow some full hybrids plus plug-in hybrids. It's not meant to be a way of banning full hybrids. At least that's the thinking at the moment. Obviously, the consultation may change people's minds if everybody suggests something different, but that's kind of the opening assumption that we're starting with. So people shouldn't think that this is just a backdoor way of getting rid of full hybrids from 2030. That's unlikely to happen. The next stage of the consultation, and I don't believe there's a date for that yet, will be what happens with HGVs, because clearly in the long term, HGVs will need to be zero emission if the UK is going to meet its 2050 targets. Equally, a ban from 2030 or 2035 would be absurd. The UK's, again, assumption at the moment is that the heavier the vehicle, the more attractive hydrogen becomes, and we'll look at hydrogen in more detail a bit later. So a 40-ton truck is unlikely to be powered by a battery, at least by a battery of any sort that we have today. So hydrogen looks like it's in pole position for heavy vehicles, but again, the task is to set a target, not to define technology. But when that technology will become feasible is going to be subject to a consultation with all interested parties. Now, obviously, zero tailpipe emission doesn't mean 100% battery electric. There's kind of an assumption that one is synonymous with the other amongst the public. But this is about defining the ends, not the means. Nobody said it has to be 100% battery electric. It just has to be 100% zero emission. I use the word just has to be. We all know how difficult that's going to be. But clearly, there are different alternative technologies. There's battery electric, there's hydrogen, which is likely to be a smaller player for passenger cars, although there is an argument that says that for large SUVs, hydrogen fuel cells might make more sense, because if you have a large SUV that weighs 2.5 tons with a diesel engine, once you electrify it, that's going to be over 3 tons and could even be 3.5 tons. And at that point, you think, well, this is ridiculous. We've got a passenger car the weight of an HGV. That makes no sense at all. So again, we will see how the technology develops, but it's all about getting to the ends, not saying what the means should be. And of course, there is a kind of a dark horse in the race, which is sustainable fuels. It's possible to create an artificial fuel by taking waste CO2 and adding it to hydrogen to create a synthetic hydrocarbon. When I say synthetic, it's not. It is a genuine hydrocarbon. It's just a man-made hydrocarbon rather than relying on a million years of nature to produce it for you. There are people who are working on that, and the British view is it's worth looking at, and we should keep an open mind on it. Whether it could be produced in scale at a competitive cost in the timescale we're looking at is an open question, but that's really one for the scientists rather than one for the politicians. Oh, sorry, there we go. Screen is having a few problems here. Sorry, I'm unable to. There we go. Thank you. Sorry,
that's okay.
Local problems. Thanks, Peter. So it's worth putting into context the UK government expenditure on UK automotive R&D, because these targets haven't just come out of thin air. The UK has been very committed to developing low carbon propulsion for quite a long time now. Really, the big turning point was 2013 with the Advanced Propulsion Centre, which is a 10-year programme, and in fact will go on for more than 10 years now. But the initial announcement was a 10-year programme, which was very sensible because it was deliberately given a target well outside election cycles, so it became completely apolitical. So the £1 billion is made up of £500 million from government, £500 million from industry, although the industry contribution is in terms of time costs rather than actual cash. That's been hugely successful. It's financed many hundreds of projects and led to some pretty chunky pieces of research getting into production. And that's covered everything from more efficient petrol engines, more efficient diesel engines, through hybrids, plug-in hybrids, range extender hybrids, and battery electric and fuel cell. Obviously, over time, the emphasis has shifted from more efficient ICE engines towards new forms of zero carbon propulsion. Then there's been, in the intervening period, quite a lot of money to develop connected and automated technology for cars, but that's not really the subject we're here to talk about today. The emphasis has once again, in the last couple of years, been on zero emissions propulsion. So 2019, the industrial strategy announced nearly £400 million for batteries and the rest of the EV powertrain, because of course, in terms of a traditional car, a battery simply replaces the fuel tank. It's the store of energy. It doesn't actually drive the car, which comes as a bit of a surprise to many members of the public who think an electric vehicle is just a battery on wheels. So driving the electric revolution is about the drivetrain between the battery and the wheels. So motors, power electronics, drives, EDUs, electric drive units, combining motor, differential, gearbox, all in one unit, for example. And then last year, the ATF, the Automotive Transformation Fund, was announced. Now, that's had a slightly difficult birth simply because of events. It was announced as an intention in 2019 with an announcement due to follow at the beginning of 2020. Of course, an awful lot happened at the end of 2019, the beginning of 2020 that delayed things. We did finally get an announcement in the spending review a couple of weeks ago, and that is the initial tranche of £500 million has been confirmed. It doesn't mean that that's the end of the story, but that's the initial tranche for the next few years. There may be more to follow, and that is all about converting the conventional powertrain supply chain into a supply chain that is ready for zero emission vehicles. So companies can apply to that if they want to develop any component that could go into a zero emission vehicle. And that doesn't mean it has to be a finished product or module. It can be the very much the upstream components. So it could be a company that wants to move from, for example, producing steel for engine components into producing electrified steel that can be used in motors production. So it can be any level of component, and it could be a company that wants to convert from the existing supply chain, or it could be a company that wants to enter the supply chain for automotive for the first time because it's traditionally been an electrical specialist rather than a mechanical specialist, so it sees an opportunity to come in. Or of course it could be a company, a startup company in Britain that's developed a new type of motor, for example, and we have plenty of those. We're fantastically good at developing new technology in that area. So it could be a company that that's developed a new motor design that looks really promising, gives really good results, but isn't yet manufactured at scale. So it's really trying to be comprehensive and covering all the bases that you would need to create a really strong zero emission supply chain in the UK. Peter, could you move to the next slide, please? Thank you. So a few more details of what I was talking about. The Faraday battery challenge is split into 3 parts. First is fundamental research undertaken by British universities, and of course the lithium ion battery itself was invented by a British university, Oxford, in the 1980s, but Britain didn't have the facility to scale it up, so it was not exactly given away to Sony, but it might as well have been given away for the long-term benefit to the UK. So we rather want the next generation of batteries to be invented here, and so there's a fund of about £80 million to undertake fundamental research amongst a consortium of leading British universities. The second stage, which is also about £80 million, is collaborative R&D to take that technology that's been developed in the UK and scale it up for production. And then the third stage is the Battery Industrialization Centre, BIC, which is opening now in Coventry, and that has the balance of the money. So that's just over £140 million, which we'll look at in more detail in a moment. But broadly speaking, it's a giant battery production facility that makes no batteries for commercial purposes. It's all about developing new technology to manufacture batteries and testing new chemistries and new technologies to give companies developing in the UK a real edge. Then we have £80 million for driving the electric revolution. So as I said a moment ago, it's all about the technology that is required between the energy coming out of the battery and actually driving the road wheels. And that's mentioning the £500 million that's just been confirmed for the ATF. So next slide, please. Now, this is a forecast made by the industry itself. So this isn't government making vague forecasts about how brilliant the UK batteries industry is going to be. This is what the UK OEMs and tier ones have come together through the Automotive Council and through the Advanced Propulsion Centre and said, obviously, this is anonymised data, but it's their data, to say what the demand is going to be through to 2040. So we believe it's going to be, we're going to need 13 gigafactories, assuming each gigafactory is 15 gigawatt hours. The number of 15 gigawatt hours isn't just made up. The logic behind that is having spoken to a lot of battery manufacturers around the world, the general consensus is that the most efficient size for a battery line or a battery factory is about 15 gigawatts. And you can scale up. You could have 3 of these in one area and have a 45 or 50 gigawatt hour center of battery production. But 15 gigawatt is kind of a logical size for one unit. And we are assuming that by the mid-2020s there'll be price parity. Now, that's a term that's sometimes slightly misunderstood. price parity in terms of total cost of ownership, it really is ambitious to think that a battery electric vehicle is going to come off the production line at the same price, because the motor and the power electronics for a modern electric vehicle aren't much cheaper than the cost of a basic petrol engine to manufacture. So the cost of the battery is always going to be additional to that. But as the cost of battery comes down, then it becomes clearer and clearer to people that within a few years of ownership, they'll be ahead by buying an electric vehicle. Not least in the long term, one has to assume that the residual value of an electric car as we get closer to 2030 will get stronger and stronger relative to a conventional car. I mean, when the first battery electric mainstream cars were introduced, nearly 10 years ago now, 2012, 2013, the residual values in the first couple of years were terrible, which is to be expected because nobody wants to be the first person to buy advanced technology secondhand that nobody really understands. Everybody's standing back and going, oh, you try first, let's see how it works out after 5 years. And as people have learned that actually batteries are lasting longer than first thought, and there don't seem to be any horror stories of massive repair bills for anything else on an electric vehicle. Just in the last 2 years, residual values of electric cars like Nissan Leafs have really improved and are starting to approach parity with conventional cars. And clearly, as the ban approaches, then people are going to be more inclined to buy an electric car, so there'll probably be a residual value benefit to them as well. Next slide, please. Now, the UK is in a very strong position to be a big player in the battery industry. Britain's always had a very strong chemical supply chain back to the days when ICI was the dominant force. Sorry, one for the younger listeners there. ICI may not exist, but most of its factories still exist. It's just different people own them. So we are very strong, especially in the north of England, both northwest and northeast, possibly northeast even more so, have a very strong chemical supply chain. And of course, that's very convenient for the Envision AESC factory that supplies the Nissan Leaf, which it should be said was the first high volume battery manufacturing plant for automotive in Europe. Obviously, by the latest standards, its capacity is pretty small. It's not a 15 gigawatt hour plant, but it was the first volume plant in Europe, and we certainly intend being highly competitive. Next slide, please. Sorry. So that's just to put it into perspective, and then we have the battery factories. Now, obviously, as we all know, batteries are still expensive. They're still over £100 per kilowatt hour at the pack level, but there are really only three things in terms of their constituent parts that make them expensive: the cathode, the anode, and the electrolyte. So if you can have a strong position in those three parts of the supply chain, that's really all you need. Everything else is is not terribly important at the cell level. So we have a very strong position in cathodes. Johnson Matthey is investing heavily in that area, obviously a big UK company. We have a strong position through Phillips 66 in anodes, and Mitsubishi, who've invested quite heavily in the Northeast in recent years, Mitsubishi Chemical, has big capacity in Europe. So we are one of the critical factors over the next 10 years won't just be increasing European production of batteries, which is a strategic priority. We definitely don't want to be getting the majority of our batteries from China for all sorts of reasons. But we need to localize the supply chain, and that's slowly being understood. There was actually a European Union report only a few months ago that actually warned the EU commissioners, saying it's all very well focusing on batteries, and that's good, but if all the component parts for the batteries are still coming in from Asia. It hasn't really got us very much further forward. We need to localize the supply of the components as well. And the UK is in a very strong position to help with that, both for UK production of batteries and pan-European production of batteries, for the reasons you can see there. We have a very strong early position in the major component parts of a battery. So next slide, please. So these are the targets which have been agreed by the UK industry, again through the Automotive Council, in terms of where we want to get to by 2035. Some of those already we look like we're probably, these were set about 2-3 years ago, and we look like we're probably going to exceed them. Possibly the hardest one, or most complicated one, is recyclability, because everything else is about improving the technology, whether it moves to solid state or whatever. The technology is broadly understood of what we're going to have to do. Recyclability is a really big issue, because clearly the whole point of making an electric car is sustainability. And if the batteries, which are the most valuable part of the car, and by weight arguably the single biggest part of the car, if they're not sustainable, then what have we spent all this time, money and effort doing? So we have to make the battery packs recyclable, and batteries are very complicated devices with an awful lot of components. And of course, the whole pressure coming from the car industry is that they must be more and more compact, more and more densely packed together. And the more that happens, the more difficult they become to separate at the end of their lives. So the UK is financing a lot of R&D into figuring out how we can meet all those conflicting targets, making them both more compact and denser, and yet easier to take apart when they come to the end of life. At the moment, batteries, when they come to the end of their lives, are generally just shredded. Extracting anything valuable from them is very complicated and quite often not cost effective. Well, that has to change. It's simply not an option that we do that with millions of unwanted batteries in the 2040s. We have to have come up with a solution by then. And the UK is pioneering a lot of the work in that area. Next slide, please. So this is the Battery Industrialization Centre that I mentioned earlier. And as you can see from that slightly complicated chart, the idea is that it can handle any element of battery production. So right from the beginning, where the powders come in and mixing the slurries, through to assembling the cells, and then putting them into packs and producing the packs ready for production in a car. There is no part of the process that can't be done at BIC. And for those people who are familiar with the catapult network, it's like a giant catapult, but only for battery manufacture. So it's a giant engineering toy shop where companies can come along and test new chemistries, new manufacturing techniques, new assembly techniques for the pack, without having to invest in their own capital equipment first. So they can perfect the new technology or prove the technology isn't going to work, which is equally valuable because it saves them money and means they can move swiftly on to a different idea that might work. So it gives them the opportunity to do the testing without having to make really heavy capital intensive expenditure first, because as we all know, battery plants are massively expensive things, and you have to be absolutely sure everything's going to work before you buy the equipment. So this is all about accelerating technology development and de-risking technology development. It gives them an environment where engineers can come along and get straight to work. The only agreement they need to get from their financial controllers is, please can we rent some time in this factory, which is a lot more affordable than please can we buy some equipment that we hope will lead to a breakthrough, but we can't be sure. So we think it can greatly accelerate the process of technology development, which is good both for the the automotive world in general, but particularly good for the UK, because the more solutions that are found in the UK, the stronger our battery supply chain is going to be. So next slide, please. Moving on to charging. I was just talking to Peter about this before the session started, about how range anxiety is declining in importance as people get more used to electric cars, and the ranges are getting up to a much more reasonable level now. But the thing that hasn't yet been solved is recharge anxiety. The fact that the charging point you're planning to go to may be 50 miles away and you've got 100 miles of range, that's great. But can you be sure it's going to be working when you get there? Will you be able to access it? Do you have the right payment mechanism for it? All the hygiene factors, you might say. And that's a big issue for people. And really what we've seen with Tesla is people are buying into a charging network as much as they're buying into a car. The Tesla supercharger network is superb, and Tesla owners know when they turn up, it's going to work. They're going to be able to plug straight in because it's only designed for one vehicle, and they can have a cup of coffee while it's charging. And so Tesla's de-risked the recharge anxiety of electric cars, and all credit to them. They set an example for everybody to follow. So the UK is very aware that this is a solution that has to be found. So as with all complicated problems, there is no one solution. It's a question of how do we chip away at each part of the problem. So one of the problems is in urban areas, how on earth can you create enough charge posts? You can't have big, clunky, 3 or 4 foot high devices every few hundred meters on residential roads. It would look awful. It would probably mean that disabled pedestrians would have real problems with the pavements. So we have to find new solutions. And again, the UK is looking very carefully, well, not just looking very carefully, but investing in applying those solutions. So last year I came out of my flat in Southwark in London, which is by no means a pioneer in these fields, and was delighted to see a car plugged into the lamppost charging overnight. Obviously a fairly slow rate, but if it's overnight, that's fine. So it's creating an environment which is adaptable to the different constraints that people have, because not everybody's going to have access to a fast charger all the time. So we're installing lamppost charging. We're looking at curb charging, just very small devices on the edge of the curb, which don't get in anybody's way, but can still be used for slower AC charging rates, and also bi-directional charging. We were the first country to start doing tests on that. And it's no coincidence that the only European car manufacturer today which can handle bi-directional charging is the Nissan Leaf. Now, in terms of government commitment, the government's putting a lot of money into this. So a couple of years ago, it announced a £400 million charging infrastructure fund. And in the spending review only 2 weeks ago, there was an announcement of £1.3 billion to accelerate the rollout of charge points. And one of the most important things, relatively small in terms of technology, but massive in terms of convenience, importance to the actual users, is insisting that fast chargers accept pay-as-you-go debit cards, because it is absolutely nuts that you can go along to a charge point and discover, oh, you've got the wrong card for that particular charge point. In what other area of life do you have to go along to a shop and make sure you can only use their store's charge card and you can't use anybody else's? So we're very aware that that's a problem that has to be solved. Now I'm just seeing a question come in, so let me have a look. Saying there's development for funding supply chains. What is available for integrating technologies into vehicles and scaling up manufacturing? What are we doing to stimulate vehicle manufacturing? Okay. that's a perfectly reasonable question. So as we've seen, there is a lot of money for R&D to develop the technology and the components to go into vehicles, but there is also money available for the manufacturers to scale up. So a lot of the money that the APC has dispersed, has given to people in grants, is pretty carefully divided up between SMEs, tier ones, and OEMs. So most of the OEMs in the UK, not all, because it depends on what technology is being developed in the UK, but JLR, Ford, Nissan, so on, have had APC grants for developing and productionizing new technology. So, for example, Ford got quite a lot of money from the UK to develop technology for EV transit vans, because the development centre is in Darlington in Essex. It was using a lot of the UK supply chain. I accept the transit body is not made in the UK, it's now made in Turkey, but there was enough value coming into the UK supply chain to make it worthwhile. So we are very aware that every stage of the chain has to be looked at, but I can assure you that there's no bar on OEMs applying, and there have been plenty of, if you look through, I won't quote every single grant because there are now hundreds of them, but if you look through the Innovate UK website and see who the APC grants have been issued to, you can see that OEMs have had a fair share of the money. It says ICE car production is currently in 5 or 6 countries in Europe mainly. Will there be further concentration? Will there be further concentration? I don't think necessarily. I think the race is on that countries that have IC car production will want battery manufacturing facilities of their own, because they accept that given the battery is such a large part of the value of the car, that if they're not making the batteries, then they're not. They're missing out on a lot of the value chain. And I should say that's particularly important for the UK, because the UK has always been a centre of development and production of petrol and diesel engines. So traditionally, the UK has made a lot more engines than it's made cars, and it's designed a lot of engines as well. So we're very much a drivetrain specialist in Europe. So if there's one country that needs a strong EV supply chain, it's us. So I don't think it will necessarily lead to concentration, but if a country that's producing, a medium-sized car producer, let's say 1 million cars a year, has no battery production facility of its own, that does make its car production vulnerable in the long term. It doesn't mean they stop overnight or the 2031 car factories stop, but you wouldn't want to be going through the 2030s as a car manufacturing country without having any battery production facilities of your own. That would make you look very vulnerable, because shipping big, heavy, expensive battery packs long distance isn't the best solution. It's possible, but it increases your costs quite significantly. So you would want battery, certainly battery pack production close to hand, and the closer you can have the batteries to the packs, the better. So in conclusion, I'd say not automatically, but it could lead to some concentration, unfortunately, for countries that don't succeed in getting battery production facilities. Right, sorry, I'll go back to my
If I could interrupt 1 second, Jay. We had a comment from Tim Harper. MEV Limited is a UK-based manufacturer of low-cost EVs. And like what we'd heard about regarding additional costs, but I may have to ask Tim to sort of further embellish what he means by that, because it might be me, but I'm not certain.
Well, I think it depends. Well, without wanting to prejudge anybody, I think a lot of it depends on what category of car you're talking about. So clearly, if it's small quadricycles in terms of the legal definition, L7E, I think is the legal definition, then sub 10,000 entirely possible. A full M1 car with the safety and ADAS equipment that customers expect under £10,000 is very difficult, car companies themselves have said, a lot of them have said that they are cutting back on the city car segment, and in the UK, the city car segment has fallen by 50% this year, way more than the overall market, which is down 30%. City cars now taking about 4% of the market. 10 years ago, it was 8 to 9%. So it's really dropping sharply, because the cost of electrifying very small cars is pretty much the same as electrifying medium-sized cars. So it proportionally takes, the battery becomes a more and more expensive part of the car as you get smaller and smaller and cheaper and cheaper. So a lot of car companies have said, we're not going to replace our current city cars at all. We can't make the numbers add up. So we're going to see fewer and fewer cars available. I mean, for example, Ford have now moved out of the A segment, and the original 1990s car used to have 40% of the UK A segment. It was a really strong player, and Ford have said, we just can't make the numbers add up. And a lot of other car companies have said the same thing. So small, cheap A segment cars which meet consumer requirements, it's a tricky one. Car companies say they're finding it almost impossible to do it. So I don't think there's going to be a huge selection of full M1 cars which are powered by electricity under £10,000. Unfortunately, I would love it. I'd buy one, but it is a tricky one, I have to say.
I think there may be one more question in, or would you prefer to go to the next slide first and then come back to it?
No, let's. All right. Yes. Battery swap. This, logically, it makes so much sense, and I completely understand the reason behind the question. There was a company that tried very hard and spent many hundreds of millions of pounds trying to develop this service, an Israeli company called Better Place, that failed about 2015, 2016. Now, talking to people in the industry, one of the problems was that if the battery is going to be swappable, they had to be swappable across more than one model. They had to be a common size and shape. Once you've established that the cars have a floor pan, a platform, which is a common size and shape, it doesn't leave much room for manufacturers to develop individual looking and feeling vehicles. They start becoming commodities, and that really was something the car manufacturers found very off-putting. There was only one manufacturer that was interested in the idea, which was Renault. Now, whether it was Renault corporately or whether it was just Carlos Ghosn who thought it was a good idea, it's hard to say. Renault were interested in the idea and looked at it quite carefully, but doing it with just one manufacturer didn't make a lot of sense. There are people who've looked at it for public service vehicles, for buses in urban areas. It might make sense. And for example, Transport for London did look at this, but they came to the conclusion that the land requirements for keeping a stock of large batteries for buses in such a tightly packed city as London, again, they couldn't make the numbers add up. You could put the battery packs in lower density area on the edge of London, but then you're adding more mileage to the buses, so you kind of lost the point of doing it. So it's one of those ideas that makes logical sense, but actually making it happen is very, very, very difficult, because either you've got to convince a huge fleet operator like Transport for London is easily big enough to make that happen if they insisted on it for buses. But they have problems with it, and for passenger cars, it would mean getting the car manufacturers to agree. And given we've spent 10 years arguing amongst the car manufacturers as to what plug the electric car should have, getting them to agree on a common shape for a battery pack, that would be really ambitious. So let's carry on. Yes. So one of the other factors that's really, really important is clean electricity. I mean, if the battery factory is being powered by coal, for example, it's just a Dieselgate scandal waiting to happen. Batteries are very energy intensive to make, let alone the fact of electricity that's being used to drive the cars. So wherever you're making the battery has to be fossil fuel free in the long term. You can get away with it today. Nobody's not nobody, a lot of the public haven't quite cottoned on to this issue, but it will only take a couple of newspaper scare stories or a couple of TV documentaries and they'll become aware of it pretty quickly. So Britain is really committed to developing clean electricity grid, and we are the world leaders in offshore wind by a long way, not even marginally. Nobody's even close to what the resources we're putting into it. And those figures showing what's happened over the last 30 years from 1990 to 2019 shows how much zero carbon's gone up and fossil fuels gone down, and the trend now is accelerating really sharply. So the figures for 2020 are phenomenal. The most recent quarter 2, 62% zero carbon. That's not just a freak figure because in the summer we didn't have to burn as much oil or hydrocarbons. The figure for the first quarter was 61%. So it's now becoming a really strongly established trend. And the government announced in its 10-point plan for carbon reduction a couple of weeks ago that the target now is to treble offshore wind by 2030, and the amount of offshore wind that will be produced on average will be the total electricity demand of the UK. Now clearly that doesn't mean every day we can get all our power from wind because it's extremely variable, but it means on average we can get our demand from wind, and obviously there will be other sources of supply which will also be zero carbon to balance the grid. So Britain has a hugely important story to tell when it comes to attracting investment in both batteries and electric vehicles, because there's now an emerging controversy about what is the break-even point of an electric car. And by that, I mean that the amount of CO2 it takes to make an electric car is a lot higher than a conventional car because a battery needs more energy to make than an engine does. Now, exactly what the break-even point is depends on how big the battery is, how big the car is, where it's being made. But Polestar, who are themselves, they only make hybrids and zero-emission cars, so they've got no reason to be harsh on batteries, say that on average you're looking at about between 50 and 70,000 kilometers currently of driving an electric car before it produces less CO2 overall than a petrol car, and we have to get that break-even point down. And if you can basically power both the battery manufacturer and the battery use from a wind farm, then you can bring that break-even point right down to close to zero, and then you're getting a benefit from the car pretty much from day one. So that's a really important factor. Now, I said I'd talk about hydrogen, and this is something we're looking at strongly, mostly for larger vehicles. And the second picture there is the largest vehicle of all. That's a 320-ton mining truck developed by Williams Advanced Engineering, company that span out from Williams Formula One, which is just phenomenal. It uses fuel cells, 8 fuel cell stacks to generate the electricity to power the battery. And we're talking, we're not talking kilowatts here, we're talking megawatts. I think it's 1.2 megawatt. Phenomenal amounts of power, as you can imagine, to drive 320 tons. And although it looks a pretty scary vehicle, it's actually incredibly environmentally friendly in that it's a completely circular energy system. So the mines have huge solar panels which generate electricity to electrolyze the water, which creates the hydrogen, which then powers the battery. So it's actually a slightly surprising example of a circular economy. It's in day-to-day use, it's actually producing less CO2 in terms of its motive power than an average small car, which is a remarkable achievement. And the UK is also investing heavily, broadly in hydrogen fuel cell technology. And Bosch gave a big vote of confidence in us, I think it was last year, in investing heavily in one of the UK emerging companies that's is developing a fuel cell that doesn't need the very expensive metals, hence it's called steel cell. It doesn't need the rhodium, palladium type metals that you get in a exhaust catalyst, and that could be a major breakthrough for cost effectiveness of electricity generation from fuel cells. So next slide. So this is the final one, and really it's not specifically about EVs, but it's putting them into an overall context. So for years, people in the industry have talked about CASE, connected, automated, shared electric, but really that's shaking out now. And whereas we saw 4 equal areas of importance, that's no longer the case. Connected is still very important, because consumers expect connectivity all the time, and secondly, connectivity offers huge safety improvements. So for example, cars will be able to warn other cars behind them that they've encountered a patch of black ice or a broken down car or some other obstacle in the road, so the following car will be already have its safety systems prepared to react to what's happening, or can react in advance by slowing down or putting on its hazard lights or whatever. Automation, what we used to call autonomous, but autonomous is kind of going out of fashion as a term. Level 5 autonomy, where you can jump in your car in Birmingham and drive up to a holiday home in Scotland, is now so far in the future that most people don't think it's worth worrying about. It's now about advanced driver assistance systems. It's about helping the driver rather than replacing the driver, except in very specific environments where you can define the boundaries, like an airport, and automate everything within the boundary. But if you can't define a boundary, full autonomy is looking harder and harder to implement. Shared is not exactly flavour of the month. Who wants to share anything at the moment? And electrification is absolutely the key. No car company is going to disappear if they don't produce a level 5 car, but they are going to disappear if they haven't mastered zero emission technology. So that's the existential threat to them, and R&D budgets are being reallocated accordingly. So that's apart from my contact details, that is all I have to say.
I could, if you don't mind, there's one question that I'd let you sort of finish before, as we're sort of probably out of time, but what's the strategy to reach 90% recyclability target by 2035? And will the UK establish commercial scale lithium?
Well, I can't guarantee we'll establish commercial scale lithium production. There are investigations going on in Cornwall right now, with some government help, to look at the feasibility of producing our own lithium. So that's a question that's being looked at. We don't yet have an answer. In terms of how will recyclability be done, well, there is a program that started, I think, 2 months ago, again financed through the APC, which is seeking over the next 18 to 24 months to answer that question. Firstly, given current batteries, how can we establish cost-effective ways of taking them apart and disassembling them, not just shredding them? And secondly, how can we work with the industry to design batteries in such a way that we don't add to the cost, we don't add to the size, but we can make changes that will make it easier to disassemble and recycle them. So clearly, if we can design the batteries with recyclability in mind, we can get to a far higher percentage, because a battery that's being manufactured today is going to be very, very hard to get to 95% recyclability at any affordable cost. Anything is possible if you throw enough money at it, but at a realistic cost, it's very hard to see how a battery made today could be 95% recyclable. So it's both questions have to be addressed simultaneously. How can we recycle what we've got, and how can we redesign what we've got so it's easier to recycle in the long term? And there's a program going on right now to try and come up with those answers. We don't yet have the answers, but we're working on them.
Thank you, Jay. Thank you, everyone, for joining. We're a little bit over time, but really appreciate the presentation. We've had another question in, but if you want, you could always sort of answer directly to that. Do you want me to give it and then we call this one as the last one, or?
Oh, is this for additional policy support?
That's the one, yes.
Right. Let's see. To support. Well, is the current level of incentive sufficient? Given the rise of EV market share, I think we're up to 6% so far in the UK this year. From a couple of years ago, it was just 1%. So clearly we're going in the right direction, and the slope of the graph is getting steeper and steeper, which is great. We've announced a huge amount of money just this year, 1.3 million for charging infrastructure, 500 million for ATF, and there are continuing incentives to buy electric cars. So obviously it's something that has to be kept under review to see how it's going. But at the moment, it is going pretty well. We are, as of today, late 2020, we're probably ahead of where we thought we would be a couple of years ago. In 2017, if somebody said what's the likely share of battery electric cars in the UK, we're probably ahead of that at the moment. So we're going in the right direction, but the government keeps this under constant review. That's why the finance packages, apart from the APC, which was 10 years deliberately, most of the finance packages are around about 3 to 4 years, so that we can look every 3 or 4 years and go, okay, that's working well, let's continue it, or we need to spend more in this area, or that area has done really well, and actually we can start cutting back because we are absolutely on the glide path to where we want to be. So at the moment, I'd say the signs are positive, but we need to keep reviewing it constantly.
Thank you, Jay. Thank you, everyone, for watching and contributing. And let's all keep safe. Take care. Thanks, Jay. Bye.
Thanks. Bye.